Hi everyone. Let's start about how to find remainders with a simple example. What is 15 into 6 into 10? You can easily calculate that 15 into 6 into 10 is equal to 900. What is the remainder when 900 is divided by 7? You can see when 900 divided by 7 the remainder is 4. Okay. Now we can also find out the individual remainders when 15, 6 and 10 are divided by 7. 15 when divided by 7 gives you remainder 1, 6 when divided by 7 gives you remainder 6, 10 when divided by 7 gives you remainder 3, right? And 1 into 6 into 3 gives you 18, 18 when divided by 7 gives you remainder 4. So either we divide 900 by 7 and we get remainder 4, or we find out individual remainders by 7 and multiply them and then divide this by 7 to get again remainder 4. So either you find out the product and then find out the remainder, or you find out the remainders with individual multiplicants and then multiply those remainders and again then find out the remainder. Okay. The second method would prove to be simpler in many cases. Here's a simple question. What is the remainder when 1998 into 1999 into 2000 is divided by 7? You can see that if you start multiplying 1998 into 1999 into 2000, it will take a long time. Okay. So instead of finding the complete product, what I do is I find out the remainders with individual multiplicants. The multiplicants over here are 1998, 1999 and 2000. So 1998 by 7 gives me remainder 3, 1999 by 7 gives me remainder 4 and 2000 by 7 gives me remainder 5. And 3 into 4 into 5 gives me 60, which when divided by 7 gives me remainder 4. Now you can see how easy it has become to break up a product into multiplicants. Let's extend this logic. So what is the remainder when 1999 raised to power 10 is divided by 7? Now you can easily see that what I'll do first is I'll write 1999 raised to power 10 as 1999 into 1999 into 1999 10 times, right? So now when I'll divide each multiplicand by 7, I've already seen that 1999 divided by 7 gives me remainder 4. That was in previous example. So 4 into 4 into 4 10 times. Now I have to find remainder when 4 to power 10 is divided by 7. Okay. Now you can use many methods over here, but the simple method would be to find out a power of 4 which gives me remainder 1 with 7. I repeat, you have to find out a power of 4 which gives you remainder 1 with 7. Now 4 square is 16, which gives you remainder 2 with 7. 4 cube is 64, which gives you remainder 1 with 7. So I know that 4 cube gives me remainder 1 with 7. So I'll break 4 raised to 10 as 4 cube into 4 cube into 4 cube into 4, right? So when I divide individual multiplicand by 7, 4 cube would give me remainder 1. So I have 1 into 1 into 1 into 4, which would be 4. And 4 when divided by 7 gives me remainder 4 only. Okay. So realize that by finding out 4 cube, I have made my job much simpler. Now let's extend this question a little more. You would understand the simplicity of what we are doing. So let's say if you have to find out remainder when 1999 raised to power 200 is divided by 7. First of all, you'll divide 1999 by 7 as we have seen before. So we'll get 4 raised to power 200 when divided by 7. I have to find out the remainder. Now again I know that 4 cube gives me remainder 1 with 7. So what I'll do, I'll write 4 raised to power 200 as 4 cube into 4 cube into 4 cube. How many times? 66 times. Okay, that will give me 4 raised to power 198. The remaining is 4 square. Okay, so this is 4 cube into 4 cube into 4 cube 66 times into 4 square, and 4 cube I know will give me remainder 1. 4 square is 16, which gives me remainder 2 with 7. So 1 into 1 into 1 66 times into 2, that will give me 2, and remainder would be 2. Okay, now you can see how finding out a power which gives me remainder 1 with 7 has made my job easier. Let's see another example. What is the remainder when 25 raised to 50 is divided by 9? Straight away, first of all, I'll divide 25 by 9, which gives me 7. So I have to find out the remainder when 7 raised to 50 is divided by 9. Now 7 raised to 50, again I'll have to find out the power of 7, which gives me remainder 1 with 9. Okay, so 7 square gives me 49, which gives me remainder 4 with 9. It is not giving me remainder 1. So I see the next power, which is 7 cube. 7 cube is 343, and I see that 343 gives me remainder 1 with 9. So I'll break 7 raised to 50 as 7 cube into 7 cube into 7 cube up to 16 times into 7 square, right? So 7 cube will give me remainder 1 with 9, so 1 into 1 into 1 16 times, and 7 square is 49, which will give me remainder 4 with 9. So remainder I'll get when 7 raised to 50 is divided by 9 is 4, or 25 raised to 50 when divided by 9 gives me remainder 4. Okay, again you have to see two things over here which we are going to do while finding out remainders. First, I'll divide the higher number with the divisor to get a lower number, right? So 25 I have reduced to 7 raised to 50 by 9. Then I'll have to find out the power of this number 7, which will give me remainder 1 with 9. I repeat, I have to find out the power of this number, which will, when divided by divisor, give me remainder 9. Okay, and that power is nothing but phi of the divisor. Okay, we have studied how to calculate phi of a number. Phi is the number of numbers less than and prime to a given number. So phi of 9 over here is 6. So 7 raised to 6 when divided by 9 will give me remainder 1. Let me make you understand what I am doing. The rule here is that if a and n are coprime to each other, the remainder when a raised to phi of n is divided by n is 1. Okay, so a raised to phi n when divided by n gives you remainder 1 if a and n are coprime to each other. So for example, phi of n is 13, so 11 raised to 12 will give me remainder 1 with 13. Similarly, 10 raised to 12 or 5 raised to 12 will give me remainder 1 with 13. Since again phi of 24 is 8, so 13 raised to 8 will give me remainder 1 bit 24, or 7 raised to 8 or something like 17 raised to 8 will give me remainder 1 bit 24. Similarly, phi of 7 is 6, so 31 raised to 6 will give me remainder 1 bit 7. Okay, so my second step in calculating remainders was to find out a power of the dividend which will give me remainder 1 with the divisor. So that power is nothing but phi of the divisor. So what is the remainder when 5 raised to 101 is divided by 7? Okay, now I have to find out a power of 5 that will give me remainder 1 with 7. I know that phi of 7 is 6, so that means that 5 raised to 6 when divided by 7 will give me remainder 1. Okay, so I'll break 5 raised to 101 as 5 raised to 6 into 5 raised to 6 into 5 raised to 6 up to 16 times into 5 raised to 5. Now 5 raised to 6 I know will give me remainder 1. So the problem becomes 1 into 1 into 1, and up till now 5 raised to 5 will give me remainder 3 with 7. So I'll get 1 into 1 into 1 16 times into 3, and remainder would be 3. One more example. What is the remainder when 37 raised to 50 is divided by 24? Again, I divide 37 by 24, I get 13. So I have to find out the remainder when 13 raised to 50 is divided by 24. Now I know 13 and 24 are coprime to each other, so I find out phi of 24. So phi of 24 is equal to 8. As I say that 13 raised to 8 will give me remainder 1 with 24. So 13 raised to 50 I can break as 13 raised to 8 into 13 raised to 8 6 times into 13 square. Now the remainder would be basically 1 into 1 into 1, and 13 square is 169 when divided by 24. That again gives me remainder 1. So remainder is basically 1 into 1 into 1 into 1 and so on. That will give me remainder 1 with 24.